This is the last portion of our section in Algebra 2 on families of functions on section 2.6. You're looking at another parent function of f of x equals 3x plus 3. What we're going to do here is show you how to reflect that function over both the x and y axis. First, let's graph it. Of course, hopefully you know how to do this. If I look at 3x plus 3, 3 is going to be my y-intercept, and the slope is up 3 and over 1, down 3 over 1. However you want to graph it, just make sure it has a positive slope. So basically that would be our parent function. Now we're going to let g of x be our transform function again. And in our first example here, we are letting g of x equal f of negative x. Now, what we're asking you to do here is replace x with a negative x in our function. What that's going to do, let's go back to our notes here. It's basically what we're doing right here. Right, if I can get this to move down. It's going to do this. It's going to reflect our graph, our line over the y-axis, that we're replacing the x with a negative x. So let me show you how that's done. With the function, what we're going to do with the actual function is we are going to replace the x with a negative x. So it looks like this, n plus 3. Then we're going to simplify that. A negative x times 3 is a negative 3x plus 3. And we're going to graph that. I'll use a different color here, but as you can see, it will successfully reflect it. Let's see, let's switch colors here. So if I graph this, it's still going to cross at 3, but now we're going to have a negative slope, negative 3/4 slope. And let's see if we've accomplished our goal of reflecting. Again, what kind of reflection is this? Basically, look back at your notes. Anytime you have a question, you can see what we said here. It's a reflection over the y-axis. Get this thing to cooperate here. Now there, okay, so it should be over the y-axis. Let's see if we accomplished that. I think we did. And what a reflection is a mirror image of the red line to the black line. It's over the y-axis. So if I would sketch, you know, a line down right on the y-axis, right down the middle, should be a reflection on each side. And you can see that does accomplish that. But that's basically the transformation of reflecting over the y-axis. You replace the x with a negative 1 and simplify. So it's a very simple topic there. Okay, now what we're going to do is apply reflection. In this particular case, g of x is our transform function, and it's equal to a negative f of x. That is just like the reflection that exists here. So if we sketch this, it should reflect our original parent function over the x-axis. So we're essentially demonstrating these two right here. So let's show you how that works. Show what this means when we say g of x equals negative f of x. Essentially what that means to you is that you're going to take your parent function, which is 3x plus, so it's g of x equals a negative 3x plus 3 in parentheses, making sure we apply the negative to all the terms in our function. If we simplify that, we end up with a negative 3x minus 3. Okay. Now if we sketch this graph, again I'll use a different color, we should end up with a reflection. If we go down to negative 3, there's our crossing point. That's the y-intercept. And if we go up 1, 2, 3 over, we want to go left, so we go downhill with our line. 1, 2, 3 over 1. 1, 2, 3 over 1. You can see the line formed. Okay. And what that is supposed to represent, and it does, a reflection over the x-axis, which is this axis. One graph is the mirror image of the other. So it's a fairly simple task to reflect functions. You take your parent function, which is provided to you in the directions. If you want to reflect it over the y-axis, you just insert the negative x right here into the function. We just simply replace the x with a negative x, and that will automatically reflect it over the y-axis. If you want to reflect it over the x-axis, sorry about this, then you're essentially going to just apply a negative to the function itself. So notice it's very important that you use parentheses to apply that negative to all the terms in the function, and that will reflect it over the x-axis. So hopefully this made sense to you. Let me know if you have any questions, and thanks for watching this video.